Hey, hi guys, welcome to Velotio Tech Shots again. I am Aniket Rajput, working with Velotio as a data engineer. I have experience in building ETL and ELT pipelines, and I have worked on various data tools, data warehouses, databases, and clouds. Today, we will be presenting a short intro on data lakehouse, combining a data lake and a data warehouse. Today, we will be presenting short intro on data lakehouse, combining a data lake and a data warehouse. We are going to cover what is data lake, what is data warehouse and their limitations. Then we will see what is lakehouse and its architecture. Also, how this lakehouse architecture solves the cons of data lake and data warehouse. So the first one is what is data warehouse? A data warehouse is a type of data management system that is designed to enable and support business intelligence activities, especially analytics. Data warehouses are solely intended to perform queries and analysis and often contain large amount of historical data. The data within the data warehouse is usually derived from a wide range of sources such as transactional databases, transactional systems, and many other sources. Right. A typical data warehouse often include the relational database to store and manage the data. Then we will be having an extraction, loading, and transformation solution for preparing data analysis, statistical analysis, reporting, and data mining capabilities. Then typical data warehouse will have a client analysis tools for visualizing and presenting data to business users. So the limitations of data warehouses are the first one is like the rigid, inflexible architecture, right? In this modern age, a business needs to be more adaptable and agile than ever before, and this requires an IT architecture that can be changed very quickly, right? However, a traditional data warehouse is not flexible and can become a bottleneck in meeting the business requirements. To illustrate this, with a traditional data warehouse, a simple change to a data model can take weeks or months to complete, and the entire process can cost thousands of dollars to your business as well. Second one is the lack of data flexibility. So data warehouses are not flexible enough to store huge unstructured data. Data warehouses work very well with the structured data, but aren't meant to work with unstructured data, such as social media and streaming data or logs analytics. The third one is high implementation and maintenance cost. Implementing and maintaining databases can be costly. Running queries over huge amounts of data ends up in building lots of units. Also, the data warehouse applications are limited to only BI and SQL applications. So we can only have a business related queries on the data warehouses that can be filed, right? The main issue and maybe the most common issue would be a vendor lock-in. So this is a common term for a situation where an organization wishes to transfer its business away from one of its vendors to another vendor, but they are unable to do so due to the projected cost, duration, or compatibility or complexity of switching. So these kind of issues are very common when switching from one warehouse vendor to another data warehouse vendors. The next one is what is data lake, right? A data lake is a centralized repository that allows you to store all your structured and unstructured data at any scale. With traditional data warehouses, stores data in hierarchical dimensions and tables. A data lake uses a flat architecture to store data, primarily in files or object storage. A best example of object storage anyone can relate is AWS S3. All the uploaded files on S3 are treated as a separate object. Companies use data lake often for data science applications. Limitations of a data lake. The first one is the data lake doesn't support ACID properties, right? Data lakes built on clouds do not support deletes or update information. This becomes a significant challenge for implementing solutions like change data capture or solutions where history needs to be maintained. Data lake have sluggish query performance. Queries executed on top of data lake using traditional queries, a querying engine like Hive or even Athena will not give a data warehouse comparable performance. As the volume of data fed into data lake grows, it becomes at the expense of performance, which is already slower than other alternative data storage systems. The third one is data complexity. So data lake involves such a large volumes of data that data scientists and data engineers are typically the only two users able to sort through them. Professional skills are generally required to pull data analysis from these huge amount of data lakes. Data quality issues. The fourth one is the data quality issues. Sifting through data lakes is a time-consuming process. Data lake require regular data governance to manage and maintain data integrity. Without proper care and attention, a data lake can become just a data swamp with unrecognized and unusable data that lacks clear identifiers and metadata information. The next one is a lack of proper data security and governance. Conventional cloud data platforms are good at storing data, but not so good in securing it and enforcing data governance rules. You will need to graft on security and governance. So many organizations face the need to use both together. For example, one big data lake and multiple purpose built-in data warehouse. This often results in increased complexity and cost as data should be kept consistent between both the systems. So all these disadvantages can be removed by converting the data storage architecture into a lakehouse architecture. So then what is data lakehouse, right? A data lakehouse is a new open data management paradigm that combines the capabilities of a data lake and data warehouse in simple words. It's like a data warehouse. Um, it's like a data warehouse, but on data lake, say S3, for example. This means that it is a data lake. In Lakehouse, you can store structured as well as unstructured data. And Lakehouse also behaves like a data warehouse where the data stored can be queried by SQL interface for analytics and reporting. So let's see the architecture of a Lakehouse now, and then you can get the bigger picture of it. So you can see here, basically, a data lakehouse system will consist of 5 layers. So first one will be the ingestion layer. The second one will be the storage layer. The third one will be a metadata layer, and this metadata layer is an important layer. The fourth one is API layer, and the fifth one is consumption layer. So let's see each of them in a little, right? So the first one is an ingestion layer, right? The first layer in the system takes care of pulling data from a variety of sources and delivering it to the storage layer. We can use batch pipeline or streaming pipeline for data processing. This layer may use different protocols to connect to a different bunch of internal and external sources such as relational database systems, NoSQL databases, social media file shares, or websites, etc. The second layer is a storage layer. The data storage layer of a data lakehouse architecture is responsible for providing durable, scalable, and cost-effective components to store and manage vast quantities of data. The lakehouse design is supposed to allow keeping all kinds of data in low-cost object stores, such as AWS S3, right? The third one is the metadata layer, the foundation of the data lakehouse that sets this architecture apart from all other architecture is the metadata layer. It's a unified catalog that provides metadata. Metadata is basically a data giving information about the other data. So it's a unified catalog that provides metadata for all objects in the lake storage and gives users opportunity to implement and management features such as ACID transaction to ensure the concurrent transaction see a consistent version of the database. Caching to cache files from the cloud object store, indexing to add data structure indexes for fast query making, zero copy cloning to create copy set objects, and the data versioning to save specific versions of a data. As we mentioned earlier, the metadata layer also makes it possible to apply data warehouse schema architectures such as stars or snowflake schemas and provide data governance and auditing functionality directly on the data lake, improving the quality of the whole data pipeline. Schema management includes schema enforcement and evaluation features. Schema enforcement allows users to control data integrity and quality by declining where any writes that don't fit in the table schema. Schema evaluation enables changes of the table's current schema in compliance with dynamic data. The next layer is API layer. The API layer provides purpose-built components to perform a variety of transformations, including data warehouses, style SQL, or a big data processing, or near real-time ETL. So this layer is responsible for converting your raw data into a read consume data. And the next layer is the data consumption layer. So the data consumption layer hosts various tools and apps such as Power BI, Tableau, and others With the lakehouse architecture, the clients have to access to all data stored in the lake and all the metadata. So how lakehouse solves all these cons that data lake and data warehouses has, right? So the first one is the asset transaction support. So as you know, ACID stands for atomicity, consistency, isolation, and durability. So these are the key properties that define transaction and ensure data consistency and reliability. Such transactions have long been available only in data warehouses, but the lakehouse presents the capability to apply them to data lakes too. So this solves the issue with the low data quality of a latter when many data pipelines involve concurrent data reads and writes. The next one is the schema enforcement. With the lakehouse design, users will be able to control the schema of their tables thanks to the support of schema enforcement. So this is used to prevent the accidental upload of a garbage data and evaluation. The next one is easily scalable. We can scale our data up to petabytes of a size with less complications. We don't need to follow any database design module. Low cost for developing and maintaining lakehouse compared to modern data warehouses. So this cost very cheap. So this is basically very cheap. Better data governance, versioning, and security. Finally, the data lakehouse architecture brings about condensed schema and the data governance procedures that make it easier and enterprises to incorporate robust data governance and security instruments. The main issue we talked about data viruses was the vendor lock-in, right? So here you can see the low vendor lock-in issues. Over time, most organizations basically store their data in data lakehouse in open standardized format, typically either in Apache Parquet format or ORC format. As a result, a large ecosystem of tools and applications can directly work with these open data formats. This approach of storing data in open formats at very low cost has enabled organizations to store large quantities of data in data lakes while avoiding vendor lock-in. And also the applications are not only limited to BI and SQL application. We can use the Lakehouse for BI SQL application as well as along with the data science application. Thank you so much.